Hello students, so this is the Earth Science Reference Table review for the Regents exam, and today we'll be talking about earthquake, P wave and S wave travel time. This is page number 11. So before we actually start with this, we are going to do a quick overview. So we are going to talk about focus, epicenter, seismic waves, seismograph and seismogram. Okay, so what is a focus? So let's just say that this is our planet Earth. Okay, sort of. And then we have the Earth's crust, the outer layer. Okay, let's just say this is the crust and this is the surface. Okay, so an earthquake happens when there is a break here or there's a movement here. So wherever we have the break, it's called the focus. And directly above this, on the surface of Earth, this place is called the epicenter. Okay, so when an earthquake takes place, there will be two waves released, and they are called the seismic waves, and there are two of them. One is the primary P, another is the S. Now you need to know the difference between these two. So the P wave, it is released first, and then they are released at the same time, but P wave is fast. This one is comparatively slow. P wave, it can travel through any matter, so solid, liquid, whatever, gas. This one S, so it's only solid. Okay, P wave is comparatively less destructive. This one is more destructive. Okay, so next we have seismogram. Seismogram is an instrument that is used to keep track of this P wave and the S wave. So you can actually find out the distance. And seismogram is a report produced by the seismograph. Okay, so that's a quick overview. Now I will actually look at page number 11. So as I said, that the P wave travels faster than the S wave. So let's just see why is that, or how that works. So let's just say I am at this location. So at this location, you can see this is the P wave right here. If you look at the S wave, it's here, and this side you can see is the travel time. So the distance, when it's 1, you can see it takes a little bit more than 2 minutes for the P wave to arrive, and it takes exactly 4 minutes for the S wave to arrive. So if I have a seismograph installed as this location, okay, so I can detect the P wave just after 2 minutes, but the S wave will come after 4 minutes. So as you can see, if the distance is increasing, so this is the distance from the epicenter. If the distance is increasing, you can see the separation time is getting higher. So if you're here at 3, you can see it takes 5 minutes and 40 seconds, and this it takes 10 minutes. Okay, so we'll see from here now. So one thing that you also need to know about the travel time in the epicenter. So here it's going by 1 minute, you can see. So in between there's a small line, it's going by 20 seconds. So if I am here, that means this is 2 minutes and 20 seconds. Okay, so each of this line is going by 20 seconds. This one, it's multiplied by 10 to the power 3. What that means, if I have 10 to the power 2, that means 10 is multiplied twice, which is 100. So 10 to the power 3 means 10 is multiplied thrice, so it means actually 1000. So if this is 1, this actually means it's 1000 kilometer. Okay, and what about these lines? So this is 1000, so this must be going by 200. So you can see this is 0, 200, 400, 600, 800 and 1000. So this is going by 200 kilometer. Okay, so this is going by 200 kilometers, and here it's going by 20 seconds. So this is really important for you to know. Now another very important thing that you need to know about finding the epicenter is that you cannot find the epicenter using one seismograph. So let's say I have, let's just write it here. So let's say there is a seismograph installed at Manhattan. Okay, and now from here I can actually tell the distance, that okay, the P wave and the S wave are arriving after 4 minutes or 5 minutes, and I can find out the distance, say, right? So maybe it came from 1000 kilometers away, but remember, it can only tell me the distance. It cannot tell me from where exactly it's coming from. So it could be from this side, or it could be from the other side. It could be from here too. So that means I have to draw a circle. So from a seismograph, it could be anywhere, but the distance is 1000 that I know. So using one seismograph, you cannot. So let's say this is station A, okay, at Manhattan. You cannot say where is the epicenter. Let's just say I have another seismograph installed in Bronx. Okay, this is B, so this is the position, and here also it came from 1000. Sorry, I don't have enough space. This is not a perfect circle, but you know what I mean, right? So this is another one. Now when you draw the second circle, you can see there is an overlap. So I can now predict that the epicenter must be from this area, right? So this is common for both A and B. Now if I have another one, let's say I install another one at C, which is in Queens. So this is station C, and let's draw another circle here. Now you can see this is the place where you have this one touched. There is an overlap of all three. So this is one, this is the second one, and this is the third one. Okay, it draws perfectly. So this is the epicenter. So you need to have 3 seismograms report from 3 stations to correctly locate the epicenter. Okay, so this is really important. Now let's go back to this. Okay, so as I said, if you are going far away from the epicenter, the separation time will be higher. So if you look at here, you can see it's increasing. So the more you are away from the epicenter, the difference between the P wave and the S wave will be higher. Okay, so that's most important things that you need to know about the P wave and the S wave. Now let's look at some of the questions. So we are going to look at questions from this book. So I am using this one. So if you solve this book, this is a really good one. So I am on page number 125 of this book, and let's look at question number 1. So how long would it take for the first S wave to arrive at a seismic station 4,000 kilometers away from the epicenter of an earthquake? So we are looking at the S wave, and we already know that it's coming from 4,000, right? So where is 4,000? We know that 4 means 4,000, and it's talking about the S wave. So we follow this line and see where we have the S waves. If we keep going up, we see that we are somewhere here, right? This is the place. So now remember, this is going by 20 seconds, right? So this is 12, then we have 12:20, then we have 12:40. So the answer must be 1, 3. Okay, let's try another problem now. So I'll solve like 4 or 5 questions from here so that you will have idea what's going on. Okay, so let's try number 2. A P wave takes 8 minutes and 20 seconds to travel from the epicenter of an earthquake to a seismic station. Approximately how long will an S wave take to travel from the epicenter of the same earthquake to the seismic station? So first of all, they're talking about the P wave, and it takes 8 minutes and 20. So where is 8? This is 8. 8:20 must be here. Okay, so this is they're talking about the P wave. So let's follow this line, and we are here, right? Take the S one out. They're asking about the S wave. So now if we go up, this is the S wave, right? You can see if you're here and if you follow the line, this is the S, and if you follow this tells me it's 15 minutes. So if the first wave, that is the P wave, comes at 8:20, that means the S wave will arrive at after 15 minutes. The first one arrived at 8:20, and the second one going to arrive at 15 minutes. Okay, so now let's try number 5. I think you can easily solve 3 and 4, similar type of questions. Okay, number 5. So the diagram below represents 3 seismograms. So remember, seismograms are the report produced by a seismograph, showing the same earthquake as it was recorded at 3 different seismic stations. Remember, I told you that you need to have 3 stations to correctly locate the epicenter, and I explained the reason. So this is station A, this is B, this is C. You need to know that the first one is hours, the second one is minutes, and the third one is seconds. So if you look at the station A, we can see that the P wave, you can see this is 8:20, and this one is 8:25, right? So this must be going by a minute. So this is 8:20, then this one must be 8:21. So this is 8:21, right? So P wave arrived at 8:21. What about the S wave? This one arrived at exactly at 8:30. So the difference is 9 minutes. Remember, I told you that if you are going far away from the epicenter, the distance between the time difference between the S and P wave will keep increasing. So the question we have here is, which statement correctly describes the distance between the earthquake epicenter and these seismic stations? So A is closest to the epicenter and C is furthest from the epicenter. B Number 2, B is closest to the epicenter, C is closest to the epicenter, A is close. Now we're gonna look at the difference between the P and S. So the first one is 9 minutes. The second one, remember, is going by 1 minute. So this one must be 8:19, and this one must be 8:26. So that is 7 minutes. Okay, let's look at the last one. This is, you can see, P arrived at 8:16 and the S is at 8:21, which is so you have only 5 minutes. So obviously the station C is the closest to the epicenter because the difference between the S and P is only 5 minutes. So the answer is 3. Okay, so I'm going to solve one more question. Question number 6, and there are 4 of them, so this will be the last that I'll be solving. Then you can try set number 2 and other questions by yourself, and if you have any question you can comment here. So let's look at number 6. So base your answers to question 6 on the diagram and map below. The diagram shows 3 seismograms of the same earthquake recorded at 3 different seismic stations X, Y, and Z. The distance from each seismic station to the earthquake epicenter have been drawn on the map. A coordinate system has been placed on the map to describe location. The map scale has not been included. Alright, so number 6. Approximately how far away from station Z is the epicenter? So where is the Z? We can see this is the Z, and the time scale minutes, you can see this is 3, and this is the P wave, and the S wave, we can see it's 6. So there is a problem. The problem is we only have the difference, which is 3 minutes. So we need to find a place where we have the difference between the S and P is 3. The best way to do this is to be accurate. We're gonna check what 3 minutes looks like. So you need a piece of paper and correctly mark 3 minutes here. So this is 0, right? If this is 0, this is 3, so you can see this is a 3 minute, right? 1, 2, 3. Okay, so the scale that I just made is 3 minutes. So now we're gonna move on and see where it exactly matches. Where it matches, this is, so this is the place. You can see this exactly matches, so that means this is where we have the seismograph installed. So these are the 2 marks that I need. So this is 1, this is 1. So this is now we're gonna read this value to see what we have. So they're asking how far away. So this one, remember, we are going by 1000, so this is 1000, and we know that this is going to be 200, so 1200, 1400, 1600, and this is 1800, and you can see this is the answer 2. So remember, if you have the difference between the S and P, you need to create a scale. Okay, so this is exactly 3 minutes, and then you slide it and see where it exactly matches. Okay, then you can easily find the actual distance. Okay, so that's number 6 A. The answer is 2. Now what about the B? Let's try B, what it's saying. The S waves from this earthquake that travel toward Earth's center will be deflected by Earth's magnetic field to be totally reflected off the crust mantle interface, be absorbed by the liquid outer core, reach on the other side of the Earth faster than those that travel around Earth in the crust. So remember we talked about the S waves, the difference. We know that the S can only travel through solid. Okay, so that means it will be absorbed by the liquid outer core. Okay, so that's BE. The answer is 3. Okay, now C, seismic station X is 800 kilometers from the epicenter. Approximately how long did it take the P wave to travel to station X? So this is a similar type of question that we did before. Let me just see. So seismic station X is 800. So we already know that these lines are going by 200. So 800 is here. Okay. So approximately how long did it take the P wave to travel? So we are talking about the P. So if you follow this line, we are somewhere here, and we know that it's going by 1, then 20, 40. Okay, and this one is in between this line. See, this is not exactly touching this line, so if it's in between, so this must be 1 minute and 50 seconds. Remember that each line is going by 20 seconds, and if you are halfway, that means it is 10 seconds. Okay, this is giving you very accurate time. Okay, the last one. On the map, which location is closest to the epicenter of the earthquake? So which one is the closest? So let's look at this map carefully and see what's happening here. You can see Z and Y, their circle is really big. If you look at X, the circle is really small. And if we look at it carefully, we can see the epicenter must be where we have the overlap of the 3 circles, right? So at this position, you can see we have all these 3 circles coming up. So this is where we have the epicenter. Right here is the position. Okay, so which location is closest to the epicenter? Is it E5, G1, H3, and H8? So we know it's here, so it must be the letter H. And if you go here, it is 3. So if you know coordinates, it shouldn't be a problem for you to find it. So we look at the location H, and the distance is kind of 3. This is not drawn to scale. So that's all about it. Then you can try the other questions from this page, and if you have any questions, you can comment here and I'll try to answer them. Alright, so that's all about page number 11 of the reference table. Thanks for watching the video, and I'll see you next time. Bye.